Hey everyone, if you caught us on last episode, we delved deep into search, knowledge, uncertainty, optimization, and learning, and started unraveling how AI works and how it learns from the data. Well, in today's video, we are taking a monumental leap into the very brain of AI, known as neural networks and language. And this is where things get really tricky and a bit mind-bending as well. But that's what AI Unfiltered is made for, understanding the concepts even though it sometimes bounces off our head. So without any further delay, let's dive in. Let's start with the very basics, the perceptron model. Think of it as the simplest of artificial neurons, making decisions by taking inputs, summing them up, and deciding whether to fire or not. Well, that fire or not thing is decided by our very own activation function, which acts as an on-off switch for our model. Now, how do these decision makers learn? This is where something known as gradient descent makes its way. Now, full disclosure. Understanding every nuance of gradient descent is a mountain I'm still climbing, but I tried to give my best shot. In simple terms, gradient descent is a parameter which tells the model how to adjust its settings internally so as to bring out the best results. From single perceptron, we now scale up to multi-layer neural networks, where each layer is stacked on top of each other. The magic truly unfolds inside these hidden layers. These intermediate layers is where the network performs complex and abstract computational tasks that we don't directly see. To make this stacked model even more efficient, we introduce the concept of backpropagation, wherein an error signal is sent backwards so that each and every neuron can adjust itself and bring out the best results. Okay, so how do these neural networks see or visualize something? This is where computer vision makes its way, wherein each image or an object is represented as a matrix of pixels. First of all, we were introduced with the concept of image convolution, where we put a small magnifying glass on the image or pass the image through some filters so as to extract some features like shapes and edges, etc. Then there is something known as pooling, which helps in making the data even more manageable. On combining both of these techniques, we get a very powerful architecture known as Convolutional Neural Networks or CNNs. These CNNs are the workhorses behind technologies like image detection or self-driving cars. Now, let's shift our gears on how AI understands language. This is where natural language processing or NLP makes its way. We were first introduced with the bag of words model, in which text is represented as a collection of words without any grammar or order, simple but effective in some tasks. Now we learned how to numerically represent these words, because at last, machine understands numbers. We were introduced with the one-hot encoding, where each word is represented by its vector address. But this model is very inefficient in large vocabularies. Then comes the real game changer, which is distributed representation or word embeddings. It captures words as dense vectors, encoding their semantic meaning and relationships. And suddenly, words like king and queen become even more mathematically relatable than words like king and a banana. And then they brought up the big guns, the encoder and the decoder model, and the transformer model. Okay, full disclosure again. Transformer model felt like it took a high-speed detour right above my head. It's a very complex model. But from what information I could gather and from what I could understand, it is all about feeding in the input, adding something known as positional encoding, a revolutionary concept known as self-attention, and at last, feeding all these processed information inside a neural network to give out the encoded results. While many of these terms like self-attention and few intricacies of backpropagation still leave me scratching my head, but the whole core concept of how these components work together and help in generating the language is slowly clicking. And that effort to just grasp the concepts, even if it looks fuzzy, feels like real progress. So this was the worldwide tour through the neural networks and their applications inside computer vision and language. It's clear that the more we learn, the more we realize how much more we have to learn. But that's what AI is all about, right? If you found this unfiltered look helpful, make sure you like, share and subscribe. And let me know in the comment section which concepts are you grappling with currently. Until next time, keep learning, keep building and stay curious. This is Venan signing off from AI Unfiltered.